So this year, the theme of our celebration is gender equality in digital transformation.
वर्ल्ड टेलिकॉम डे निमित्त पुणे मॅनेजमेंट असोसिएशन व टेक फोरम यांनी आयोजित केलेल्या कार्यक्रमात सुरेश शेने यांनी सर्वांना सर्व माहिती सांगितली. 5G टेक्नॉलॉजी काय आहे, की भविष्यातील याचा वापर कशासाठी होईल याबद्दल सांगितले. त्याचा आभार आपल्यासाठी.
Welcome to World Telecom Day, and Pune Hams Tech Forum and Pune Management Association jointly celebrating the World Telecom Day, 17th May 2025. Today's speaker is VU3ZIG. I am a radio operator, Suraj Sena. He is from the telecom industry and having a very good experience in telecom. He is also a avid home brewer in ham radio, and we are eager to listen to Suraj from the ham radio perspective. Today's presentation, bridging the digital divide and the power of 5G. So, without spending much time, I request Suraj to start his presentation.
Okay. It's an absolute honor to welcome you all present here. On this occasion, we are celebrating World Telecommunication and Information Society Day. And most importantly, the 160th anniversary of National Telecommunication Union. This is a core organization. It is close to the hearts of connecting the world since 1865. So, being a telecom professional, I find it my responsibility to contribute myself in this valuable occasion. And before that, introducing myself, my handle is Suraj, and I'm a telecom professional working since last 10 years on telecom sector. And I'm going to present you the basic understanding of 5G technology, 5G private networks, IoTs, and its application that will be in real life. So as we all know, 17th May is celebrated as World Telecommunication and Information Society Day. And I would like to play the message from the Secretary General of International Telecommunication Union.
Welcome to Paris on May 17, 1865. These gentlemen were here to make the telegraph work across borders and sign the treaty that will establish the International Telegraph Union. So much has changed over the years, and not just our name, to the International Telecommunication Union. ITU became a specialized agency of the United Nations in 1947. And today is known as the UN Agency for Digital Technologies. We've evolved together with technology. From the rise of radio and television, to the first satellites in space, to the internet and mobile phones, to advances in quantum technologies and artificial intelligence. ITU has always been at the forefront of tech innovation. And behind the networks on land, the sea, and in space that power the digital economy are the people who collaborate every day to make global communications work. People from government, industry, academia, the technical community, working together year-round, coordinating radio frequency spectrum on Earth and in space, developing technical standards, and building capacity for global digital development so that we can meaningfully connect the 2.6 billion people that are still offline and ensure that digital transformation works for everyone, everywhere. As we celebrate 16 decades of connecting the world, ITU thanks you for all the work you do to make it happen. Here's to 160 more years of building our shared digital future together.
This was a message from the Secretary General of IT. So as we see on the video, IT is meant for with a vision of technology for all and for good. So the story of the international telecommunication unit is one of the international cooperation among government companies, academies, and other organizations involved in communications and digital technologies. They not only support for technical development, but also for improving the skills of the people, even in a urban area or in a rural area, uh, across the globe. So this year, the theme of our celebration is gender equality in digital transformation. So as we move deeper into an era of digital communication, we know that 5G is an undisputed technology which can support connectivity between people, between devices, between communities, and all. So 5G will play an important role by connecting peoples to balance this gender equality gap in digital context. So, being ITU a part of international organization, they are already part of some kind of activities which are improving the uh, skills of especially the women and girls. So, as per the fact and figures, we see that 70% of men are using the internet globally as compared to 65% of women. So still there is a gap of around 189 million more men online than women worldwide, and that too in developing countries like Europe and USA. The gap is higher in least developed countries or developing countries, where only 29% of women are using the internet. Gap persists not only in the access but also affordability of accessing the internet services, the digital skills, participation in STEM programs, which are part of their curriculum, and also the leadership in tech sector. So as you can see, only few organizations are there which are posting women employees in higher level. But that's also a challenge that IT is pointing out. These gaps are not only disadvantaging women and girls, they also hinder economic growth of innovation in the countries around the world and achieving the sustainable development goals. So, as a part of telecom profession, um, we are contributing a small part in this big area of work that need to be completed. So, from my part, I'm giving an awareness on 5G technology. Basically on technology context like how it works and showcase some real life, real world scenarios and use cases that I think will help to improve the digital skills and understanding of this 5G for those who are viewing this program, and also promote equal opportunities for women and girls in technology. So we'll touch up basic technology and use cases related to 5G and also the role of ham radio in bridging this gender divide. So when we talk about fifth generation of cellular communication, we need to have a basic understanding of the history of cellular telecommunication. So let's have a background look. So earlier, it's all started with a normal radio, that is a radio. It can be, we can correlate that with a ham radio. It's an analog. So the predominant use case was people who are traveling or shopping or in office location should be able to receive the voice calls no matter what is the security or whatever. They just need to receive the voice call. So that was the first use case. And this retroactivity further developed, and we started naming it as first generation of cellular communication. Then comes the second generation, that is 2G. That while 1G was launched or become active during 80s, early 80s and 70s, 2G started its development and evolution from 90s. So here the only change from the first generation to second generation was the adding of voice in digital format. Earlier in first generation it was analog, pure analog. In 2G they have started digital voice. Obviously our voice signals are analog. That started to modulate in digital format. That do have some benefits like we can achieve a lot of compression, voice quality, etc. So that was incorporated in the second G, 2G. But still we are stuck on the voice communication only. There was no scope for data or internet. So 3G was the starting point where we can say that it offered true mobile internet. Even though 2G has some part like GPRS and Edge that launched in the early days, 3G has more importantly, we can say that it's a complete mobile internet. So the speeds were very slow, like nearly 100 kbps to few Mbps based on coverage and capacity. But this was not the actual requirement at the current generation level. So during that period in early 2001, 2002, this data rates were sufficient for fulfilling the use cases at that time. But nowadays, we are more into internet and Internet of Things. So then came the 4G. So 4G, we were more focusing on data rates. So how they achieved that? 4G, we can see that as compared to 3G, in core architecture, they have done some network architectural changes like separation of control plane and user plane. And then that helps us to provide more data throughputs and speeds. So even they advertise 100 Mbps with LTE advanced technology, but in real life, we know that in our 4G we can hardly get around 10 Mbps, up to 10 Mbps and 30 Mbps if you are lucky. And also 4G have introduced some additional Internet of Things that we are currently using, like Wi-Fi LED lamps and our health tracker watches, etc. So this all came from the 4G. But we think that this level of speed sufficient to capture the future needs of our telecommunication. So we know that density of mobile users are increasing yearly. So even the 4G has a bandwidth limitation of up to 100 megahertz if you are using some other additional technology like carrier aggregation and all. So there are a lot of drawbacks that 4G have that current generation will not capture. And to fulfill that use case, we need to go for next generation. So that came the idea of 5G. And 3GPP standards two set of parameters to measure whether 5G will be able to capture these use cases and all. So we only will be discussing about this 5G use cases and the background technology on that. So these are the main points that we need to understand before we go into the 5G in detail. So what are the limitations of 4G? I would like to play a video that will help you more visually understand the thing.
GEA with speeds up to 1 gigabit per second. However, for the lifespan of 4G thus far, speeds for the majority of people have averaged only between 10 to 50 megabits per second. The primary reason why speeds have been so atrocious is that region and the initial standards for 4G weren't designed with a mobile future in mind. The amount and rate of growth of devices that outpace technological ability to support them. In fact, in cruel paradox, the more devices that have come online, the slower the program have become. making advertised speeds unreachable. Secondarily, much of the infrastructure required to bring noticeable improvements in speed come with the deployment of LTE Advanced Pro. LTE Pro became Release 13 and is the final phase of fourth generation mobile. It will be with periods of the fifth generation, bringing major noticeable improvements in the coming years. Release 13 standard began in 2015 and ended in mid-2016. It builds upon the technologies of Release 9 through 12 and takes the concept of carrier activation to the next level. Carrier activation is simple training saving multiple channels bandwidth and stitching them together to make bandwidth much larger. Think of it like a single line highway getting expansion, allowing for more traffic flow through. Now, as I stated earlier, 4G LTE networks have struggled keeping up with demand mobile data because they have a limited capacity to just a single license. License spectrum are carriers provide, and as such, most commercial mobile data flows through license spectrum that they offer everyone seamless mobility and predictable performance. Carriers often have bidding wars to obtain more spectrum space for license use, and up to this point, we essentially used up a sub 4 GHz spectrum space. Much of the unlicensed spectrum reside in the 5 GHz range, where technologies such as Wi-Fi and Bluetooth provide as well. LTE allows for carrier activation of 5 licensed channels, which improves speeds and latency, but still not noticeably enough to exponentially growing demand for more bandwidth. LTE Pro support carrier activation of up to 32 channels in licensed and unlicensed spectrum, which is
So, at the current network settings over here in urban areas or suburban areas, you can, if you have noticed in your mobile where the tower signal strength is displayed, you can see that sometimes it will show as 4G and sometimes it will show as 4G plus. So the plus stands for this LTE advanced.
Okay.
But even though the maximum it can support is up to 100 megahertz, the total channel bandwidth. So channel bandwidth, I believe everyone can understand. It is just a available frequency range that one mobile can use. We can correlate that with a road. If the road is very narrow, then only one or two vehicles can pass through it. If it is a say 20 feet road or a higher broader road, then more vehicles can travel on that. So we can correlate that. So for LTE it is just 100 megahertz. So that's the one limitation.
More conversations can go in that.
This is not about the voice. Now we are talking about data. Because the voice part is completely ignored right now. We are focusing on data and things.
Yeah, they can link bandwidth and the closely sub 6 GHz spectrum much more efficiently due to the introduction of the unlicensed spectrum space. This will also significantly reduce bandwidth gaps we often deal with today, with licensed spectrum covering broad areas and unlicensed spectrums and Wi-Fi coexisting together and providing more location-specific connections for the use of small cell technology. The recording release was starting in 2016 and taped us this month, June 2017. Briefly being supporting the bulk of fourth generation mobile study, guaranteeing full-scale 5G network realization. Many technologies that fifth generation mobile networks will expand upon further in the future will begin to be deployed, including massive MIMO of 64 antennas, beamforming, and increasing the number of small cells, all in combination with carrier aggregation to ensure that high speed and low latency 4G LTE Pro connection.
We can say that these are the basic problems that we are currently experiencing when we talk about 5G. I know that Vilas already have query related why my calls are getting disconnected, why my calls are getting dropped. So these are all the reasons and limitations that the current network is having. When the number of users increase, the capacity will be very it will be narrowing. Some user will not get much experience. That is one of the drawback here, as we can say. Crowded connectivity.
Though the bandwidth is 100, but the number of vehicles are more.
Yes.
Compared to users.
Yes.
I got good.
So, on the go entertainment. So nowadays, earlier we used to just download the pictures and just watch the YouTube and all. But nowadays, number of content creators are very high. So now we need to focus on uploading. So a uplink throughput is an important factor that nowadays are coming into picture. And next one is crowded connectivity. So we know that whenever events happen in particular location, there will be huge number of users there, like stadium events and all. So at that time, we need to provide sufficient coverage as well as capacity. Even though we are successfully able to provide the coverage, if the capacity is lacking behind, then the users might not be able to use the services properly.
So in such cases, you provide additional tower or cloud
Yes, normally there is a traditional method for establishing the voice connectivity, but now there's another solution that we'll be discussing in further slides.
Okay.
Now the immersive technologies like AR, VR, etc. that need ultra low latency and near perfect reliability. So our augmented reality and virtual reality is a new subject and interesting subject. So that means very low latency. Earlier we used to have just like we think like yeah, internet is connected, if my file is downloading, that is okay. But the factor like latency, like how delayed the packets are coming, so that point was not considered in the 4G. So it was not designed for that. But nowadays, even 5G is used for mission critical use cases like surgeries, live surgeries, etc. So at that time we need to consider this latency factor also. Connected vehicles. Nowadays, I think EVs are mostly connected, but in developing countries, if I say, the EVs are connected, the vehicles are connected, they have auto collision detection system and all. So the V2E communication, these all are now connected directly to the network, like say the mobile network. So that are these for that all use cases we need a new technology. So that comes the evolution of 5G. So if we talk about 5G, it is not just an enhancement, but we can see changes in huge order of magnitude. Like the main important is the capacity. Like it gives 10x throughput. Like it is just like fiber. So if you nowadays in India, we can see that fiber is something. It's a service that provides the fastest internet. So we can replace that to 5G network to get same capacity and same throughput. Next is latency. So as I already discussed, latency has been brought down to 1 millisecond. That can be easily compared with the fiber or wired system. Next is uniform experience. So in 4G, if you see, there are the broadband thing I have explained you. Like if there are 10 customers, then the speed of every customer will be it will be decreased. Or when more number of users come into picture, the throughput will again decrease. So in 5G, we can see that we get a uniform experience. Like the speed will not drop even if more customers are connected to the network. The last but not least is low cost per bit. So significantly, there are many other technologies that we are using to bring down the cost, mainly like cloud and virtualization and all. So that will be discussing further slide. So also we have provided 10x connection density. That is number of users in the current network. 3x spatial efficiency, 100x traffic capacity, and 100x network efficiency. So before understanding the 5G, we can broadly classify the services into 3 categories based on a few set of factors. So one is MMTC, like massive machine type communication. Here only the communication happens between 2 machines. It can be 2 devices, suppose a Wi-Fi LAN or a 5G IoT device and your phone, or an IoT device to your server. So here we need to understand that in machine-to-machine communication, we just need to transfer the message in some interval of time. There is no need to continuous transfer the message or broader bandwidth requirement or anything. So that's
So it can go in packets.
Yeah, it can go in it can work in a very narrow band. We will explain more about that in the next slide. Next one is eMBB. That is mainly for high-speed internet with a high capacity. So eMBB is something we can say that's a solution that is mostly deployed in stadiums where IPLs are happening, for say, and other event areas where there's a huge crowd and need of huge capacity and throughput.
So you need totally different hardware for this?
No, this is all integrated in 5G technology.
Okay, integrated.
We are just segregating the service classes.
Okay.
The third one is URLLC, that is ultra reliable, low latency communication. That I already explained for medical related mission critical services.
Okay.
So in discussing in detail the eMBB, that is enhanced mobile broadband, we can get peak user throughput rate of greater than 100 Gbps. So if you imagine the current network system, and if you are getting this 100 Gbps throughput, so it will be very like so it's like a fiber-like connection that we are getting, and network throughput can be greater than 1 Tbps. So individual user will get a 1 Tbps, and the peak user data rate can be 10 Gbps, depending upon the signal to noise ratio and the strength of the signal and the location where you are, and also the environmental conditions. So how 5G makes it possible to deliver such peak rates? So there are a lot of technology that is being used in the background that we'll be not discussing in detail. But just for understanding, that is spectrum sharing, flexible slot-based framework, scalable OSDMA, and massive MIMO, mobile millimeter wave, dual connectivity, and advanced coding schemes. So we are discussing the main part, that is massive MIMO and mobile millimeter wave in this particular segment. Next one is MMTC. This is just for connecting the things and establishing the communication between them. Here the more focus will be on the power, because these devices will be deployed in some remote location where it need to be sending the data like temperature, humidity, or some other measurement data like sensors and all. So here we are only considering about the power supply and reliable communication. So expected power supply, like a battery life, should be around 10 years. So it will be like we deploy and forget. So example, if we can say like a utility meter.
Expected or reality also 10 years?
Yeah, reality is also possible, because it will use very low power. If you design the electronics part of the IoT in such a way that it will consume low power, then it will work. On the context of power required for transmitters and functioning of this technology, it will be very low power. Last one is URLLC. That is, as again I discussed, for mission critical applications. And here we are not considering about throughput or power. Here the more focus will be on the latency. So less than 1 milliseconds latency is supported, and the reliability and availability will be this 6-digit figure, 99.4 times 9%. So these are mainly used for real life applications, such as in anti-collision system of vehicles, in remote surgeries, etc., where we cannot adjust with the other parameters. Now, the other networking principles that enables this feature is network slicing, software-defined network function virtualization, and mobile edge computing. Network slicing is like if we have available network, we can easily program it to use for multiple applications. And depending upon the usage, we can increase the required resources for particular service. We can decrease it. Some kind of a life cycle management. And next is software-defined network. That means earlier we used to have boxes, that is vendor proprietary. That we cannot add any other software application on that. Whatever is provided, we have to use that. So now we have moved that concept from standard OEM proprietary device to servers. Like we can buy any blade server, we can install the software required for the particular application related to network, and then we can use. So we can use, it can be easily optimized. And third one is network function virtualization. So there are various levels of functions that need to be configured. Earlier, what we used to do is that in equipment there will be multiple cards that will be having each function. Like in analogy, we can say that in a computer we have sound card for processing the sound, and we have VGA card if we want to have VGA connection. USB, there will be USB card. So that kind of approach was there for multiple functions. Now all these are modified into a virtualized and in the form of a software function. The last one is mobile edge computing. So we know that we are using Facebook. and Google. And there are other websites also. Suppose we have a website for PMA here. So when we try to access that website and we try to compare the speed of launching of the web page as compared to Facebook or Google page, we can see some difference. Like PMA website will take 1 or 2 seconds delay as compared to Facebook that will be launching in a single click. So that is achieved using mobile edge computing. What they do is instead of reaching the server all the way along through the network, they provide a server near to your location, which will cache the server functionalities of the Facebook or Google or other service provider in the locality. So it will be closer to you.
For locality of 5 kilometers, 10 kilometers.
Yeah, yes. They can cache the web service there. So you can easily access that within a very short period of time. So that function is being enabled in 5G. When you talk about spectrum, we know that it is a costliest part of the network operations. So in 5G, if we can use any type of band, like even we can use the current 900 megahertz band that is used for 2G voice communication. But the only challenge is that the bandwidth, it will not function as per the requirement, because our more focus is to get a broader bandwidth and the broader capacity and the broader throughput. So when we go lower the frequency, the required throughput will not be achieved. So we have to rely on high frequencies, like say gigahertz range, that currently we are not using.
We are going up to 1800 megahertz only. Above that,
No, in 5G we have N78 band and N258 band.
okay.
N78 is 3.5 gigahertz band, and N78 is N258 is 25 to 28 gigahertz band.
Oh,
So we are more into the higher bands right now, so that the core use cases can get the more through. So here we can also use licensed as well as unlicensed spectrum.
okay.
So in unlicensed spectrum, we can say that our Bluetooth and Wi-Fi, that is operating near to 2.5 gig and 5 gigahertz,
Yeah.
we can use that frequencies also in 5G. In India, I think 5 gigahertz, some slots have been opened for incorporating 5G for free. That spectrum area.
Free.
Yes, yes. No, out of
But
number.
who can
Maybe
use it?
that can be for temporary, or maybe they can later.
But free for whom? Current operators or some other?
No, now there are a lot of OEMs here who work on 5G technology and develop their own devices.
Okay.
So they can also use that particular.
And they can treat their own network. Someone has a factory having
Yeah, they have
500 employees, so they can operate. They can have their own cell or own.
Yeah, that will be discussing next time. That is a possible scenario here. Next is shared spectrum, that we can share the license and we can combine the licensed and unlicensed spectrum together to improve the bandwidth. Now talking about the millimeter wave, that is something that is very interesting, and the main core part of the 5G. So we can see that. I will show a video for that for easy understanding.
The first of these technologies, and possibly the most important of all, is millimeter waves. From the inception of millimeter waves, all devices have been frequency spectrum between 3 kilohertz to 6 gigahertz. Now, this wasn't an issue in the past. Devices were limited to mobile phones. However, with the emergence of the Internet of Things, self-driving cars, smartwatches, VR, AR, and countless other technologies involve constant vast adoption. These frequency bands are becoming increasingly together. This rate of growth of connected devices is only like exponentially increase, with companies or investors calling for over 50 billion by 2020. If all these devices were anywhere in currently established frequency spectrum, no device would be able to get an appropriate amount of bandwidth.
So as you can see, current scenario up to 4G, the bandwidth is very limited and it is almost crowded. So for that reason, you may experience call drop and low throughput access.
So because of so many gigabyte devices getting upgraded.
Yes, because in that time the coverage of the cell also shrinks in 4G, And the voice over LT that we normally make a call in 4G depends upon the coverage and availability of the network.
But look, that voice communication is negligible. They are considered in this.
Yes, yes. Voice communication is also happening, but it is called voice over LT, VoLTE.
Okay.
That is working in separate, and the server is there for handling the VoLTE part. But when we talk about the real mobile network, in about the 5G and all, the more important is focus on data part.
Data point.
Connection. And all of the other things in just below millimeter waves, frequency spectrum from 6 all the way to 3 gigahertz, allowing for much more bandwidth real estate on a important keep in mind that we won't immediately use all that frequency spectrum. For the higher shit, it will be going centimeter waves with light and spectrum grading 0.4 up to 40 gigahertz. Services including smartphone infrastructure, self-driving cars, healthcare, and more. These services require constant high-speed and low latency connections. Therefore, a shared spectrum is key in ensuring these devices are always connected. For example, you wouldn't want to self-drive a car that blocks an issue because someone needs to go on a phone call. The shared spectrum is also designed with
So we already seen like what is the advantages of millimeter wave, and the larger bandwidth means less crowding. So these are the benefits of this particular millimeter wave. Now this is a real life scenario where the throughput and capacity provided by a single cell deployed in a suburban area with a bandwidth of 400 megahertz. So as we can see that a single cell can serve multiple site locations over here with a sufficient throughput and capacity. Now, suppose a new user want to connect to some operator. So normally, and he need a high throughput network system. So normally, what we do is ask for a fiber connection. But for providing fiber connection like this, it will be a real challenge in the sense of cost and all. So using millimeter wave, we can easily provide the same service as compared to fiber using this millimeter wave system. So this also helps in rural development area, rural development also because there is a connection called backhaul connection. That is a connection from your tower location to the servers behind the telecom operator. So normally they use huge fiber connections there. That can also be eliminated and with the help of 5G network. That will also help in reducing the cost. Now, for providing indoor and venue deployments, we have solution called small cells. So that helps us to provide better coverage in such locations where the normal tower signals will not reach. So this is an example of a real-time use case of a stadium which is occupied with 15 base stations. As you can see, the peak throughput is multi-Gbps, and typical throughput at all levels is greater than 700 Mbps for each user. In worst case, even though he is getting 100 Mbps per user.
Compared to 700. Okay, 100.
700 is the maximum he is getting. And
minimum is 100.
Minimum is 100 in worst case.
So that time the data transmission will have problem. It will be slow.
It will 100 Mbps is no. In your normal LT operation, it will be really hard, hardly 5 or 10 Mbps. This is 100 Mbps. And this is another use case where the towers are 3 base stations, 3 NR cells are deployed in a factory. And please note that inside this manufacturing factory, the area will be not linear. There will be a lot of metallic objects and all. So, and there will be challenges in line of sight. So typically for a 35,000 square feet factory, these 3 small cells give coverage as per the simulation, which ensures a downlink peak throughput of around 4.2 gigabits per second. Next is the concept of massive MIMO. This is something that enables 5G to make use of the antenna systems and antenna arrays so that it can provide the required bandwidth and also focusing the particular users by using multiple beams and all. So there's a video for better illustration of this.
Primary technology for 5G networks is massive MIMO. It's needed to provide connection for the high density of devices in particular areas. MIMO stands for multiple input, multiple output, and will be applied to cellular base stations. Currently, MIMO technology is used in a much smaller.
Okay. Earlier we know that a single antenna will be there. That will be a single element antenna. But nowadays we have an antenna array. So each this yellow curved dot will be it's an array of antenna. Okay. The single dot represents one antenna unit, and this entire unit is a array of antenna. It can be 64 cross 64, 128 cross 128, and 256 cross 256. Okay. So greater the number of arrays you have, the more focus.
Okay, there will be basically PCB engraved or.
Yes, yes.
Okay.
Form with base stations having between 8 to 12 antennas to handle all the traffic at once and see. Massive MIMO takes this idea and expands on it with the ability to have hundreds of antennas per base station. This year,
Yes, yes.
But multiple companies such as Huawei, ZTE, and even Facebook successfully demonstrated 96 to 128 array systems. The number of per base stations only today says testing and defining areas. It is expected by 2020 the average consumer will have at least 6 to 8 connected devices, bringing 3 with more regular. If you multiply the single person with the population in some cities, you can begin to see why massive MIMO is so effective in providing consistent connectivity. Massive MIMO ended one being to provide connectivity to over 1 million devices per square kilometer, which is enough to provide quality in the city limits, stadiums, and other community packed areas where current 4G systems often fail or struggle. Although with massive MIMO is the interference that all these intersecting ways of creating a high type.
So this type of MIMO antennas, we can even focus our signal energy to particular user. So earlier what we do is that the antenna will radiate in all direction. Suppose in this case, suppose the antenna is like placed like this, it will radiate all signals in all direction. So there might be chances where some user is sitting just outside the coverage of that particular antenna energy, but he will not able to access the network. So using massive MIMO, instead of transmitting the entire energy in one direction, we can focus it using narrow beams towards a particular direction, particular user. So that feature is something important that can provide the user a better experience. Also, the single antenna can create multiple beams horizontally as well as vertically.
Multiple beams.
Yes, and can handle multiple users based on his needs. Suppose
So earlier days we used to turn antenna. No.
required.
It can be done through software.
Yes. Next is beam sweeping. So beam sweeping is an important feature that 5G can do with the help of MIMO. So beam forming and beam sweeping. So as I told, the antenna will be capable of generating beams focusing to particular users as per the requirement. Also, it can help in beam sweeping. The same antennas will have to increase the coverage of the cell.
It will happen automatically or manually here.
This all things happens in algorithm. 5G will automatically detect.
Here is a civil society where the usage is very low. But here there is a cricket stadium and maximum number of people are operating their digital mode as well as analog mode,
Yes.
other voice mode. So the beam sweeping will automatically happen and they will get more back.
Yes. So beam sweeping is like it will first create a set of beams, like as we say, and it will start sweeping around the area. Suppose a cell tower location is having a coverage of 5 kilometers. Using this beam sweeping, it can increase the coverage to say 7 kilometers or 9 kilometers just for sweeping.
Okay.
So once it sweeps and it identifies the user presence there, then it will automatically create a beam towards a particular user,
Yeah.
even is outside the particular coverage. So this
So
one,
this can be seen with the pixel meters at various locations.
this can be simulated,
Simulated.
or you can measure, but this thing cannot be visually.
Usually, I got your point. But this is something that steady antenna through software, it is beaming in different directions.
Yes.
And it is sweeping also.
So this helps to identify. This will act just like a radar. If some enemy aircraft is coming, then our radar will detect. Yeah, this aircraft is located in this direction. So this feature helps to detect the user, his location, and his.
Provide according to the power as well as the build strength.
Yes, and also the service classes we earlier seen, that are
So during the night time, the power will be low and the consumption also will be low.
Yes.
Okay.
In that, you can adjust it automatically using the algorithms. So these are the benefits that I already explained of massive MIMO.
Yeah.
Now this is a real world experience. Real world use case, where using the MIMO, this black line shows a 2x4 MIMO. Like there will be array of 2x4, 2x2 antennas into 4 antenna array. So with that, the user will produce around 808 megabits per second. Okay, but with a 20, when we increase the MIMO count from 2x4 to 24x4, there is a significant improvement of 4.1x. So even if we increase the MIMO capacity by more, say 128 cross 128, the throughput will be very higher. This will give more idea.
Higher frequency.
Let's see. The
The
beams are automatically formed.
not necessarily aiming for a particular target. When you're defined procedure for especially
Earlier, we used to transmit the signals in all directions, but after massive increase in that,
the inform acts like a crossing guard, only sending out signals exactly where and when they are needed by spatially planned until they reach their target device. Lighting massive amount of light warrant as the base stations. They will also warrant the target length as well, link 4 to 16 plus. This addition of antenna is key for being more allowing for more precise, advanced spatial tracking. The submission of antennas will allow devices to connect with the destination and vicinity to establish line of sight communication. Taking it one step further, the informant will be spatially aware enough about signals of obstacles in the environment to ensure they reach their target location. Before we begin discussing the next technology, I want to play this clip of the following technologies we discussed thus far working together in this.
So what the research center did is they took a fixed solution and they added adaptive beamforming to it. So when you can get a millimeter wave for high gain antenna,
this is a mobile device.
you might have a range of 4, 8, or even 16 in many antennas around the device. On the base station, you're looking at numbers of antennas that it's 8, 6, or 5. Beamforming is all about setting the right amplitude and phase for each of the so it's true to me.
What is shown here? This E0B is we can compare to a tower. Okay, and this is the antenna of that particular tower.
Beamforming is all about setting the right amplitude, phase for each of these elements. So that collectively they steer the lane in a certain direction. This has to be done by one. You can think of it as a spotlight on stage, where a performance on stage is moving around, the spotlight kind of follows. So when we see our GUI or our UI, you see like a spherical design of the image, most scientific in terms of providing the performance. So depending on the
UI is moving and the beam is.
depending on which
Now you can see the beam will switch from first tower to second tower
that's what
automatically.
The yield will changing. The cloud will be changing also.
Yes.
So physical manpower is not required for this.
Yeah, even in 4G and 3G we don't need because now the antenna comes with a remote electrical tilt, so we can configure the required tilt in our system and will automatically adjust the beams.
Beam also.
Beams.
Physically?
No, not physically.
Electrical
Electrical.
fixed.
Antenna will be fixed. Only the electrical way.
So no hardware change.
no need to change the
Again,
cable.
rather you have to go up and change it or
No, but in that case, initially we need to set the
Ah, yeah.
mechanical dip.
that is okay.
For slight adjustment, you can do it electrically. Now next is RAN evolution. So when we talk about the boxes that you use on the tower location, earlier we used to have this separate boxes that is vendor specific. This BBU stands for base station baseband unit, and this RRH stands for remote radio head. That will be connected in the tower, top of the tower. There will be a small shelter room below the tower. There we place this BBU. So in current evolution, it's changed from DRAM to CRAN and then to virtual RAM. So in 5G we are using virtual RAM. That means the radio units will be there in the tower, but the entire control system will be in the cloud. Now let's talk about the private network. So as per your query, yes, it's possible to have a private network which can be designed as per the requirement of the industry. So mostly private networks are set in in big institutions or in big industrial areas as per the requirement. So the main specific benefit is that we can tailor it according to our design requirements, and that will help to improve the or decrease the cost. And we can also use unlicensed spectrum there, so that there is no need to spend for spectrum fee. And next one is interoperability. So if you are having a subscription of private network, you can attach to public subscriber like our operator that service we provide here, but with the understanding and contract with them. But if you are in public network, like say if you are a customer of current operators, then you cannot launch into this private network.
Acha, why this doctor law?
That's for security reasons.
Security.
Okay. So, and the last one is urban cell networks and industries, warehouse, corporate, campus, etc. Though these use cases, as I told, will be applied in such areas where there's need of huge communication facility. And
Lot of confidentiality also maintained in this.
yeah, even if you see in China, they have deployed this 5G private networks in the military area.
Oh, military area.
Yeah, because there's a huge advantage of this 5G.
We don't have our
We don't have. Now next is benefits of a private network. As I told, we can optimize the network as per our requirement. We don't rely to the operators or request them to provide coverage in this area or in this particular area. And
we can take care of our area and our operation.
yes, and the most important thing is the great data security. So if you are hosting the device by our side and we are maintaining the server and we are maintaining the network, then there is a huge like important.
But is it interface with the outside operators?
No. Private network is private only.
Okay.
Like you are investing the each and every part, like the network part, the radio part, everything you are investing from your end,
Okay.
and you are keeping that system in your premises. So it will give a high engine data security. And most importantly, single private network can facilitate multiple use cases. So depending upon our requirement, we can tune it as per the service classes that we have already seen, like EMBB, MMTC, and so this concept of private networks and lead us to the industrial IoT. So industrial IoT is a application where we can see a huge number of use cases such as container ports. More specifically in container ports, we can see that there are a lot of containers and these are all metallic objects.
Yeah.
So in normal radio operations, it will be a huge challenge due to reflected signals and all. So this whole thing can be managed using 5G technology. And in oil refineries, say there are a lot of sensors deployed to measure and send the data. So and manufacturing industry, construction field, etc. Now talking about industrial IoT, this is a set of use cases that we can. I will explain one due to time limitation. I will explain this automated guided vehicle. So we are familiar with these three service classes as I discussed earlier. So let's check out this automated diagram. 5 minutes. So in automated guided vehicles is these are like robotic arms vehicles that floating in the industrial area for multiple applications. So these guided vehicles sometimes need to have communication with our operating agents to give some instruction to perform the particular task. So at that time, we need a reliability. Like it should be always available, right? It should be available when the operator needs to do some changes. So that service is provided by ultra reliable low latency service (URLLC). But at the same time, it is an IoT device. It sometimes moves in narrow pathways and will send the details like I reached this location, etc. So that is a small package of data that it will be sending continuously or limited period of time to the network. So it is also an IoT device. So in that case, we can club these two services and integrate into that particular network so that this deployment can be more flexible. So that's one of the use cases. Similarly, there are other use cases also. So in a nutshell, we can see that we can combine the service classes as per our requirements. Now, the key consideration of private network is that the spectrum, as I already discussed, we can use unlicensed spectrum for that, that will reduce the spectrum cost. And next one is network architecture. There are two types of architecture, basically SA and NSA, standalone and non-standalone. Standalone in the sense it's a pure 5G network. If you are first time you are deploying a 5G network, then you can adopt this SA. NSA in the sense if you are having a legacy network like 2G, 3G, and 4G, and you want to integrate a 5G, so you don't need to invest on the core part. Only the radio part and some part of the modification you have to do. That case you can choose NSA. Third one is infrastructure, whether you want to have a tower type or you want to install small cells to provide the coverage in some area that is hidden from core area, so you can hidden from outside area like that.
Welcome to the club.
So this use case, it will give a clear idea about comparing current Wi-Fi device, Wi-Fi wireless device, and the real 4G, real 5G device and the Ethernet cable. So first, there's an industrial machine that will be displayed here. And first, he will try to use the Ethernet cable, then using normal wireless network like Wi-Fi or something. And then third, he will be using the 5G. So we can clearly observe the use case part here.
5G and industrial IoT there. My name is Mehmet Yavuz, and I'm an interior engineer at Qualcomm. In the industrial IoT space,
Okay, I will just
as the next industrial revolution control frequency industrial equipment, I will show you 5G compared to the actual Internet cable. Here I will show you our prototype system made for taking this from, as you can see, flashing LED lights behind. To the bottom, you can see the 5G in our prototype. When we go to the second view of the prototype setup, we see the motor drives controlling the rotating discs from. These are all connected and controlled to the industrial motor controllers. And then on the top, you will see the industrial switches and logic control. We're using process switches, the leading industrial standard for automation. On the left side, you place the table requirements. In the demo, I will show you performance of Wi-Fi.
So Ethernet communication protocols, they have gone now.
yes.
Almost there.
No,
Yes.
in this use case, they are using to connect the machine to their server using Ethernet cable. In this use case, we will explain.
That is used for the interface now between machine and.
Yeah, currently in industry they are using this the Ethernet cable. So he's just explaining like what is the difference and about using the 5G in place of wired network. You can directly replace the wired network.
So a lot of wiring and clumsy mechanical things will go.
Yes. Yeah, this is actually a rotation mechanism where the LED will light up when This is a control system. Like it will provide continuous feedback.
Now back to the real demo setup. You can see here all the data is from room condition and many devices sampling. First, I'm showing you the precise motion of since the LED lights are fixed at the top of which you can only see the LED light blinking from all to the front. Here we show the wood. On top, we show the measurements of the time set the LED turn on. This
will indicate the delay, time delay.
Now we start rotating the left.
Okay, this one is running on Ethernet, so we'll be comparing the Ethernet with the wireless and then the 5G.
Now we go to 600 RPM.
That is rotating 600 RPM. So Ethernet we can see the LEDs blinking, and the delay is less than 5 milliseconds. That's pure wired network. That is expected result for a wired network.
There's a fiber line. See the Ethernet delay only 1 millisecond fiber line.
And now delay cannot be taken care.
Yeah. Now he's using some wireless network here. That is not a 5G. Okay. So now you can see the LED is not. We are unable to see the LED lightings, and also delay is more than 5 milliseconds over here.
Next, he replaced the wireless.
Now he's replacing the wireless network with 5G.
Everything must specify on the right flag. Looking at the green closing, yes, you do the line showing the 9% thermal temperature. But still much further than the game line.
Okay, now it's using 5G.
Utilize 5G.
So the 1 millisecond network delay is achievable as compared to Ethernet. So it's very similar. You can replace the Ethernet cable to 5G network. That's the use case here. So educational tool, it can be also considered as educational tool to introduce basic electronics and communication concepts. In community building, I can say that it's promoting an inclusion of technical curiosity, and we can also see that women are also in this hobby. We have a net here, we have a repeater in Pune in Ajinkya Devi Patil that is managed by and managed in the sense the daily regular night is happening by young enthusiastic ladies from Kolkata. So that's an important factor that I would like to.
Yeah, our entire cooling is operated by the ladies.
Yes. So that's an interesting thing.
So we have already employed ladies.
Yes, we are already in.
Yes, I missed that part. Yeah.
Now complementing 5G technology. So Ham Radio offers resilience and accessibility even where 5G isn't available. So with our radios we can easily establish communication at that time. Can act as a gateway to technical education, building confidence to explore digital technology. And we can also explore the opportunities to blend both, like remote monitoring using Ham Radio plus IoT.
Yeah.
So I've already shown an IoT device in the last week. We can incorporate that in the 5G network also. Now in conclusion, let's harness both emerging technology 5G and proven tools like Ham Radio. Promote equal access, skills and voice in digital age. Support women and girls in tech for truly inclusive future. So our main focus should be in any organization. We should have an inclusive approach for all the like, no matter what gender they are. So it will help us to reduce this gender gap, and we can contribute into this to make a better future.
Thank you. I think you must thank you.
We present you the book.
Yeah, we'll help you. Yeah. Thank you on behalf of Pune Management Association, Tech Forum and Pune AMS, RCP. We must thank you for this wonderful presentation. It's really an eye-opening for us because what we have learned in our education in 1970 was trousers or crossbar exchanges. And we just taken a big leap now as far as the digital communication is concerned and 5G network. So it was earlier French and Latin to us, but today with the presentation, lot of eyes and sparks have started in my mind, and I think we will continue to have this kind of a knowledge exchange in coming future. On behalf of Tech Forum, can anybody click the bottom? Okay. Yeah. Thank you. So recording will be available now very shortly. And this is not in the textbook what we have heard today. This is something really, though I did my telecommunication engineering in 1970, that time it was very limited. Faxical was a miracle nowadays. I remember seeing a mechanical facsimile in Chennai. And earlier in the newspaper, they used to run radio photo. Those days, photos they used to transmit were facsimile to all the newspaper rooms. And you used to see the photo.